All right, Brian, the official timekeeper, you want to give us a call?
Is 2 minutes past 2.
2 minutes past 2. Okay, well then we're late already. Okay, let me welcome everybody and thank you so much for joining us at our annual Industrial Partner Day of our CCOM review, or excuse me, JHC, Joint Hydrographic Center review. And I think as many of you know, and as we explained in the messages, this is a very, very different kind of setting and scenario this year. It's not the big event that we normally have, which has a day of overlap with NOAA leadership, lets you exchange. We have our nice barbecue where lots of great ideas are exchanged. And that's really in response to, one, the COVID situation where we're doing much better, but still not able to have large groups meet on the campus, but also the recognition that with the very sudden loss of Rick Brennan, NOAA needs some time to kind of reorganize, and I think it's probably best to let them organize and get settled on new leadership before we go through that process. But we didn't want you to forget about us, so we do want to at least update you on what we're up to. And so what we'll have is kind of the standard lightning, and it'll be a lightning quick presentation on my part. That will just touch, just mention the things that we're doing and mention who's doing it. And it's mostly just to let you know the kinds of things we're doing. I'm not going to touch on everything. We'd be here several hours if we did that, but just the highlights. And if you have interest in any of those things, you're most welcome to contact me, contact Brian, or contact the individual PI I mentioned and pursue that further. What I'd like to do when we're done is open it up for questions and discussions. And we really are keen to get your input from one perspective. If you think we're heading off in wrong directions, and from your experience, and that's what's wonderful having the industrial partners, is that you have sometimes a very different experience set than we do. That'll be terribly helpful to us. Or if you think there are gaps in what we're doing, if there are areas that you think would be really helpful to you if we started to pursue from a research perspective, it's really important for us to know that too. So that's what I'd like to save the second hour for, that kind of discussion. We're doing it in just a regular old Zoom session, which means that you can all just chime in. We can actually have everybody's picture on there if we want, and I'll shut the screen sharing off at the end so we can actually look at each other. We'll ask you to use the chat if you have some questions. I won't be looking at that as I'm going along, but other people will monitor it. So if something comes up and you want to kind of log a question in, you can put that in the chat and we'll come back to it. You can use the raise hand option, and if you want to interrupt, and that's fine. Or if it's really important, just turn your microphone on and shout. You can interrupt that way too, and that's fine also. But please do try to keep your microphone muted if you don't want to interrupt, and that'll make life go a lot better for all of us. If you have technical issues, Will is monitoring everything. His email address is there and his phone number is there too. And so with that, what I want to do is turn it over to Andy Armstrong for a second, the co-director of the Joint Hydrographic Center, and let him say a word or two of welcome and introduction. Andy, please.
Thanks, Larry. And Larry said, I'm Andy Armstrong, and I'm the NOAA co-director of the Joint Hydrographic Center. And I think, as Larry will explain a little bit later, there's really two centers here, two names. And the reason we do that is to allow CCOM and UNH to enter into these really great partnerships with you without dragging NOAA and the government and all that associated complication into those relationships. But that said, having this industrial partnership is one of the things that NOAA thinks is terrific about the Joint Hydrographic Center and CCOM, and that the government sort of has the benefit of our partner having these extended relationships with you all, so that when we fund the work here, we know that there's connections to the whole industry and to the reality of people out in the surveying and mapping and charting sector. So I'm looking forward to being part of today's session, and I'll let it go at that, and hope that we get to do this in person next year. So welcome on behalf of NOAA, and Larry, back to you.
Well, thank you. And I think we all share that sentiment that we certainly hope that we can meet in person next year. What I'd like to do is, before we get into the meat of what we're doing in terms of the projects and stuff, is to take a moment to say that yesterday at the NOAA review, at the government review, we took some time to remember Rick Brennan, who I'm sure that many of you knew, and who also, I suspect you know, unexpectedly passed away in May, not long after being selected as director of the Office of Coast Survey. And Rick was one of our earliest students, and through the years, he was always a great friend and a colleague. And yesterday we talked about many of the contributions that Rick made over the years. And I think they're beautifully captured by a statement that Senator Shaheen read into the congressional record in honor of Rick. And you can see it up here, and we'll have this mounted on a plaque in our conference room very, very shortly. If you haven't read that statement, I encourage you to do so. Rick's death was a tragic and really unimaginable loss to his family, to CCOM, to NOAA, and to the nation. And as much as he had done, I think what really, really hits us is how much more he had to contribute, and we'll really miss that. We hope to preserve his memory and have his legacy be an inspiration to all those who come to CCOM. And so what we did yesterday is, in his honor, renamed our conference room into the Rear Admiral Rick Brennan Conference Room. And I hope that as each of you comes to visit us, and hopefully we'll have many meetings in this conference room, in doing so, we'll get to share our memories of Rick and remember him for some time to come. That's hard for me to do. Okay, let me turn now and start the formal review. And because some of you knew, I'm not going to spend much time reviewing things and putting things into a broader context, but I will touch on that a little. And I think most of you know we began at some 21 years ago in January of 2000, although I think it was Andy and Sema who actually got up here in about July of 1999. They were the real pioneers who started to dig the hole before the foundation was poured. And over the years, we've clearly grown in numbers of people and in buildings. We've increased our footprint quite a bit, as you can see here. And the most important thing to know is that starting in about 2010, we get our funding through a federal funding opportunity, through a competitive grant. A grant is put out for a joint hydrographic center. It's not at the University of New Hampshire, and we have to compete, and we do compete with others. It's for a 5-year period. We were awarded it in 2010. We competed again in 2015 and were fortunately awarded it again. And in 2020, we submitted a proposal for the third iteration. Again, we're very, very happy to say that we were awarded the grant. So we started with that grant in January of 2021. And at the same time, we still have a little vestigial stuff left over from the old grant, and we get what's called a no-cost extension. And that's a lot of it due to COVID situations. And so we're actually this year working on both the old grant and the new grant at the same time. And I'll give you a little description about what they asked for, but I'm not going to differentiate here. We're just going to talk about what we did over the past year. And we've always kind of focused on a same set of goals from day one: to be a world leader in the development of hydrographic and ocean mapping technologies and approaches. And most relevant to you folks, to expand the scope of ocean mapping clients and constituencies through the development of innovative applications and collaborative work with both the private sector and government labs. And we've always really believed that the work of Coast Survey to support safe navigation has so many more applications. And I think the number of industrial partners we have really supports that concept. And we're constantly looking for these other things that can be do with that rich data that we collect in support of safe navigation. To look at our industrial associates, which Andy says both know and we are very, very proud of. And I ask you, if you don't see the name of you, if you're on this call and you don't see your name, please let us know. It's sometimes hard to keep track of what's going on, but we think we have a growing and broad group of wonderful partners. I constantly say, take as much advantage of us as possible. We're here to help you as much as our partners at NOAA. And we're very keen, and you'll see some examples of us working very closely with some partners. And when we do work closely with a partner like that, it's because they've reached out to us. So please do reach out to us. We're very, very keen to see this happen. It's helpful to our students. It's helpful to NOAA, and it's helpful to our faculty to really understand what's going on in the real world with real world applications. We also at the same time, have an educational mandate to educate a new generation of hydrographers and ocean mappers to meet the growing needs of both the government agencies and the private sector. And we do this through a graduate program where we graduate both masters and PhDs, and we have students coming in from a number of tracks, from a range of engineering backgrounds, ocean, electrical, mechanical engineering. We have earth science, computer science students coming in, oceanography, natural resources students come in, and of late even some more biologically oriented students. We also offer a graduate certificate program, which is shorter than our kind of 2 to 3 year masters. And that's a 1.5 year program. That's what our Nippon Foundation JEPCO students go through, and others too. And we occasionally have non-degree programs, short courses, seminars. We support surf scholars and hauling scholars. A couple of years ago, I talked about the fact that the mechanical engineering department has now started a Bachelor of Science in Ocean Engineering. And this is really important to us and really exciting because it really starts having in-house a cohort of young students who we can kind of focus into our business. And we have really expanded this year our interaction with those undergraduates in 2 ways. First, we will start in September offering an undergraduate specific course on introduction to ocean mapping that really will start in training undergraduates, and of course really focused on the undergraduates. In the past, we've had an undergraduate here or there in our graduate courses, and that makes it very difficult at what level. But now we will really have an undergraduate focused course for the mostly the ocean engineers, but others will be welcome. And at the same time, we have started a summer intern program. And we had 2 of those ocean engineering students this year who there was a competition. 2 of them were selected. One was out on the Fairweather for some time and then sent to Thunder Bay. The other is still out on the Thomas Jefferson, and they are doing fantastically. We get wonderful reports from the ship. They're getting involved in every aspect of the operations. Natalie Cook is writing a blog that if you can follow, I think it's probably on our website somewhere. It's really just remarkable to see the excitement and the enthusiasm. I think we've really entrained some people here who are going to make this a career, and that's really good. As I said yesterday, this may be one of the most important things we've done over the years. We still maintain our Nippon Foundation JEPCO training program. We compete for that every year. We're just completing the 17th year. You can see in orange all the 45 countries that students have come to us from. Year 17, Colombia, Venezuela, Ireland, Malaysia, Philippines, Russia, UK, and our new cadre of students coming from the Azores, Denmark, Ireland, Japan, Nigeria, and Sri Lanka. And this has added a tremendous dynamic to the lab. Most of them come from hydrographic agencies. It builds a huge network, and the JEPCO alumni stay very closely tied in this network after they graduate. And it's given us contacts all over the world, and that I have to say, taken advantage of many times. And so this has been a wonderful program. To date, 102 scholars graduated from it. Oop, the wrong direction. If we just take a look at the 102 JEPCO scholars who've graduated, and we've got another 102 distributed amongst PhDs, For the first time this year, we have 2 NOAA PhDs. That's the first time we've had that. Derek Sowers and Mashkur Malik. 18 NOAA folks who got masters here and 67 or so others. If we take a look at the distribution of the students we've graduated, these are non-NOAA students. Yesterday, I just showed the light blue who were NOAA people who came into our program, and the orange ones who were non-NOAA people who went into NOAA after they came out of our program. But last night, and this is incomplete because we're still trying to track down some of them, I took a look at how many of our students have gone into the private sector, and you can see it's by far the majority. So hopefully we're doing a service for you too. And I suspect some of the white names here were mostly, they're usually naval officers from other countries, folks who've gone to government labs or academic institutions, but some of them we just don't know yet and haven't tracked down. So I suspect there'll be even more than about, I think we have about 34 up here, 35 that have gone in the private sector. So again, I hope we're providing a service for you. Andy talked about these complementary centers, the Joint Hydrographic Center, which is really the product of the grant between NOAA and the university, funded mostly by the Office of Coast Survey, but with also contributions from OMAO, from OAR, the Ocean Exploration Program in particular, and other parts of NOAA. And then what you guys know most about, the Center for Coastal and Ocean Mapping. Same people, we just change hats sometimes, but what we have with the Center of Coastal and Ocean Mapping is an entity that's at arm's length to NOAA and arm's length to the government. So it allows us to get involved with each of you. It lets us get involved with other funding agencies, and we do. And this year, just to give an idea, we have about $4.5 million of funding from non-NOAA sources. And so we try to mix both our NOAA work with non-NOAA work. And again, most of this from traditional funding sources, but some of it from the corporate sector too. We are now involved with 2 other major NOAA programs that are not associated with the Joint Hydrographic Center grant, although we inevitably interact with these programs, and you'll see that as I describe things. One is the new Ocean Exploration Cooperative Institute, which is funded by OER. That's in collaboration with Woods Hole, URI, the Ocean Exploration Trust, and the University of Southern Mississippi. And in that context, we are responsible for the delivery, operation, and integration of a uncrewed surface vessel, in this case, the IX Blue DRIX vehicle. And we have purchased one through that. It just came a few days ago, just arrived in New Hampshire. I'll mention a little more about it a little later. We are also very much involved through NOP funding with Saildrone and Mabari for the further development and implementation of the 72-foot or 22-meter Saildrone Surveyor, this spectacular vehicle with a deep water multi-beam and a shallow water multi-beam, an EM304 and a 2040, a full suite of EK fisheries echo sounders, and an environmental sensor suite. That's what Mabari is running, which includes an eDNA sampler. We took part in the seagoing acceptance trials earlier in the year here in San Francisco Bay, the EM2040, shallow water, beautiful data, EM304, deep water, beautiful data. And then in mid-June, that vessel took off from San Francisco, heading to Hawaii on an autonomous mission. You can see some of the track along the way. What I wanted to do is point out the differences between motoring and sailing, swath width increasing by about 30%. So along with all the environmental benefits of sailing, we also get a much improved swath width under that mode because it's so much quieter. This transit was funded in part by the Nippon Foundation Seabed 2030 project. So we selected a route to try to maximize the collection of new data going places that have not been mapped before. I'll show you the tool we used for that in a minute. And as we approached Hawaii, where there's much more coverage, it wasn't hard to do that across the Pacific. We were able to divert and start filling in gaps moving into Hawaii. The vessel came into Hawaii last Thursday with a very successful mission. There's the entire track. The data are being offloaded. We get a limited amount of data in real time, but the full data set is being offloaded now. and we'll have that processed up very, very quickly. So we're very excited about that. I think we're really setting a new trend in the way of doing deep sea mapping. Again, I'm so sorry you can't be in the lab. Those who've been there have seen this. Those who haven't will next year, I hope, but lots of facilities in the lab in terms of telepresence activities, training facilities, spectacular Viz lab. But again, we just, you'll have to wait and see that for yourself. I talked about the grant that ended in 2020, but with a no-cost extension for 1 year. We call that the old grant. And the grant that we've just been awarded, the 2021 to 2025 grant, the new grant. Those grants come out as federal funding opportunities with prescribed by NOAA programmatic priorities. You can see the 4 programmatic priorities here from the old grant, 3 programmatic priorities here for the new grant. Beyond those programmatic, very, very high level programmatic priorities, the FFO, the federal funding opportunity, specifies, in this case, in the old grant, 14 research requirements, a little more detailed than just innovate hydrography, what they meant by innovate hydrography. In the new grant, something like 20 research requirements, again, with a little more specificity. But the bottom line is that you can see these are not very different. And even as we get to the level of the research requirements, they're not very different. The same major themes. What we saw in the more recent grant is a little more specificity, a little more focus on uncrewed systems, cloud-based system, machine learning, and things like that. All the things that NOAA is really thinking about. So those have been added to the research requirements. In each case, we respond with a proposal in the old grant with 57 individual projects or tasks, we tend to call them. In the new grant with 46 of them. Again, I'm not going to differentiate. I'm just going to tell you what we've been doing. Some of it related to the old grant, some of it related to the new grant. But again, the bottom line is not that much difference between them. If you're interested in the details of what we have been doing, and even to the task level, that is reported each year in our annual reports, which we should have something like 20 of already, including the last year's 2020. These reports are quite substantial. They're over 300 pages long, but there's a smaller, maybe 30-page executive summary there too. They're all available on our website, and I welcome you to go there to get the details, because you're not going to get any detail in terms of almost anything I'm going to say today. It's going to go through, it's going to come by so fast. You're just going to see who's working on what, basically. And with that, let me start. And so here I'm going to ask you to kind of fasten your seatbelt, and we're just going to start marching through some of these major themes. Again, old grant, new grant doesn't matter at this point. Just give you an idea what we're doing, who's doing it. And again, you'll see the names up here. If you want to contact these folks directly, or if you want to contact Brian, me, Andy, we can put you in touch with the people if something hits a chord and it interests you and you want to know more about it. So if we start with our theme of data collection, data acquisition, we start by focusing on the sensors themselves. So we've invested over the years a lot of time in trying to have facilities that let us understand the sensors we use, the sonars we use. We've built a lovely calibration facility in our deep acoustic test tank. Many of our industrial partners have used it. You're most welcome too. This year with COVID, it was not easy to get people in there, but we did have at least 3 groups come in, and we calibrated a MITRE hydrophone array. We looked at an EdgeTech semicircular array, and we looked at an IX Blue CPIX system. We also think about the fact that when we do calibrate one of these systems fully, it'll often take 2 weeks. It's a very intensive process. We can't do that for every sonar installed on every launch. So Carlo Lanzoni and Tom Weber have been thinking about ways of doing launch-based calibrations using buoys and a calibrated sphere, and that's moving along slowly. What Tom Weber, excuse me, and his students have been looking at is a kind of an intermediate way of doing this, which is, I think, quite clever. The idea is to use a chain or extended target, which acts as an analog for the at-sea backscatter calibration procedure we use. And I'll show you some of that John has used, John Hughes Clark and his students are using already. Here we basically take a calibrated sonar, an EK80, and use a traditional sphere to calibrate it. We then take that sonar and calibrate this extended target, the chain, which you can think of as kind of an analog to the seafloor. And so that process only takes a few hours. It doesn't take weeks as it would with a sphere and a multi-beam system. Once we have the chain calibrated, we can then take our multi-beam and calibrate the multi-beam against the calibrated chain. And you can see here backscatter as a function of angle here. And here you see some EK60 calibrated sonar spot checks, and it looks pretty good. So we've been quite excited about this and looking at this as a way to speed up the process quite a bit. We did have the experience this year of doing a full detailed calibration on a T50P in the tank. And when we compared our chain calibrations against that, we found that they had the very same pattern, but there was about a 3 dB offset. And so we need to understand what the issue is with our chain calibration. Once we understand that, we think we'll be in a much better position to bring that chain calibration as an intermediate step for quantifying systems. As I said, John Hughes Clark and his students are working on a standardized approach for calibrating a variety of sonars in the field. And to do this, we need to understand the response of the system for different frequencies, for different pulse lengths, for different modes of operations. And so they've been establishing procedures for doing this. And here's an example from 3 launches on the Rainier, where you basically go through every combination and build this table of response that can then be applied to the data to correct it. This, of course, though, these are data collected in Puget Sound. This, of course, is a relative calibration, and what we need to do now is combine this with the absolute calibration to make this an absolute approach. Once we know each system's behavior, how we bring that to an absolute level. Further along the effort to understand the limits and the constraints of our sonar system, Tom Weber and graduate student Jim Hamill have been looking at why there seems to be high phase noise in multi-beam systems as compared to looking at something like an ME70. Here's a phase ramp in an ME70, beautifully clean. We look at the phase ramp in a typical multi-beam, it's much, much noisier. Theoretically, the ME70 data matches the theory just right. The multi-beam data seems to be offset quite a bit from what you should theoretically be able to achieve. And so this has been a quandary. What's causing this? Tom and John have some ideas and think possibly it's a contribution from out-of-plane reverberation, basically side lobes. And so to test that, we're working with another one of our industrial partners, IX Blue, and their new CPIC sonar, because that allows us to change the shading of the transmit array on the fly. So we can actually quickly do tests of what the impact of different shading would be, different side lobe patterns. And we're waiting to collect more data using that approach, and hopefully we'll have some insight as to whether this is indeed the cause of that increased noise. So we focus on the sonar at first, but beyond the sonar, the environment, of course, is an important source of errors in both bathymetry and the backscatter data we collect. And John Hughes Clark and his students have been investigating this for some time. And here we're looking at the impact of both natural and Hull-induced bubbles on the backscatter and bathymetry we get. And this is a wonderful example from the Bigelow, where we're seeing bubble sweeps. The Bigelow has a drop keel, but the multi-beam is located on the blister. And you can see here that had the multi-beam been mounted on the drop keel itself, it would have been out of much of the bubble sweep. And so again, we're trying to get insights about what we need to do to maintain high quality in our data and see the impact, of course, of the bubbles in terms of backscatter masking and bathymetric mistracking. It's not just bubbles that affect us in the environment. There's a significant impact of our undersampling of the sound speed variability. And this, of course, also results in unwanted artifacts. And here we're looking at about 50 minutes of data collected, again in Puget Sound, in an area where we have a very, very rapidly changing surface temperature profile. This is due to solar heating. And this results in false short wavelength topography, and that's actually masking the real seafloor. So again, trying to understand all these things that are degrading the data we collect. We're trying to get the most perfect data we can for purpose. I always have to say for purpose. In further looking at the nature of temperature variability and what we can do to understand and monitor it, John Hughes Clark and his PhD student, Indra, have been looking at both ADCP data and underway MVP data along with multi-beam sonar data. So we actually can start imaging what's going on in the water column, understanding it, and then again, seeing what information we can extract, because it's also useful information in its own right. In doing this, John went back to some historic records, went into NCEI and looked at some 18 kilohertz EK60 data, calibrated fisheries sonars, and there's a wealth of that sitting around the archives. And sure enough, there's plenty of water column data in there. You can see beautiful water column structure. But amazingly, what he found was that in the 18 kilohertz EK60, there was tremendous sub-bottom penetration, up to 30 meters of sub-bottom penetration. And so again, this is a constant reminder of the wealth of information that's tied into the acoustic data we collect and the range of applications we can use from even a single sensor. I think it's just a wonderful example of that. Tony Lyons and his student, Nicholas Lamana, have been looking at synthetic aperture sonar and also finding the importance of the impact of water column structure on the performance of the sonar. Here we're seeing a synthetic aperture record collected over a piece of seafloor, trawl marks, and some other sorts of structure here. 6 days later, same piece of seafloor. You can see the trawl marks quite nicely, the darker structure there. But what in the world's happened? Well, what's happened is a series of internal waves have passed through, and there's a lensing effect, and that has a terribly degrading effect on what's collected. So Tony and Nicholas have been modeling that effect, developed approaches that are showing the effect, which can be a degradation of 3 to 4 times in terms of resolution, with the hope that we can actually do the inverse and start now correcting for this. Again, pushing to get that sonar to be as precise as possible in terms of its fundamental capabilities. And after we fixed all that, and we spend all this time and effort trying to determine what the seafloor is like for real, we've now removed the instrumental artifacts, hopefully, removed the environmental artifacts. Now we can really measure and monitor the seafloor. We have to start worrying about maybe the seafloor changes on its own naturally. And so Tony Lyons and Jen Dykstra have deployed a tripod with a series of echo sounders on it, 38,270 kilohertz, CTD, stereo camera pair, and a forward-looking camera, and getting long time series, now starting last November, and looking at just the change in the seafloor at this one spot, of course, but hopefully it'll be representative of something. We'll at least get some idea of how it is in one area, and already seeing something like 6 dB difference in backscatter through several storm cycles. So again, we're getting a feel for what the natural variability is too. No matter how well we do, there are inevitably going to be imperfections, particularly when we talk about system integration. And so John Hughes Clark and his student Brandon Magnote, I never could say that right, Mangote, I have to say, sorry, have been working on tools to understand dynamic errors, what we call the wobbles, from both a forward modeling sense, which was Brandon's master's thesis, and now with the hope of creating an analytical tool for real data, which is the focus of his PhD thesis. So hopefully we'll have a tool that will identify the errors and hopefully give us insight into how we can fix them in terms of the integration and dynamic errors. We have also focused on a series of tools that give us indications of real-time data performance. The more we can do up at front, and I think this is a quote from Doug Lockhart, who should be sitting out there, that the total cost of ownership, the cost of fixed data, increases further downstream from the source of the problem. It makes perfect sense. The more we can do up front, the better off we are. And so working with NOAA's Office of Coast Survey, our folks have been working on this HydroOffice toolkit, a number of tools at many stages in the processing pipeline. But one of the ones that has been most successful and most widely used is the SoundSpeed Manager. It's a very mature application, thousands of users, as you can see, scattered all over the world. And in this reporting period, it's been expanded to handle integration with the new SIS system and expanded formats, expanded the number of formats that it can put in, but very useful and valuable, widely used tool. We host also the Multi-Beam Advisory Committee, Paul Johnson taking a lead there. And that's now an NSF sponsored group that are supporting the UNOLS fleet of multi-beams that, again, working hand in hand. This is kind of the interchange or leverage of one task against another, creating a series of real-time data performance monitoring tools. And I think we've shown you these before, the ability to measure extinction, the ability to measure data rates, but what they've added now is a tie into historic data. So you can watch the degradation of a system if it does degrade over time, or you can go back to the manufacturer who tells you, oh no, that's what you'd expect of this system. And you can say, no, look, 2 years ago, we did much better. Or you can find in their historic records that a similar system on a different vessel actually performed much better than yours. So a very powerful tool for understanding and comparing the performance of systems. They've also created tools for creating reference surfaces and for then plotting swath accuracy in that reference surface, something that we keep coming back to time and time again. And finally, a very, very useful tool. I think we introduced it last year, but now it's been expanded. That's a web-based patch test selection tool for selecting patch test sites. And it provides all the things you need to find a patch test site, bathymetry, slopes, has layers for sound speed models, so you can know what the environment would be. You can look at vessel traffic, you look at where previous tests were done, and it will incorporate things like bags and GMRT data sets. So even in the very shallow water, we can find sites. And again, this has been used quite a bit, both within NOAA and outside of NOAA in the UNOLS fleet for finding test sites. As we continue in our data collection theme, we have a very large effort. I mentioned the DRIX, which was funded by a program outside of the Office of Coast Survey, the OER program. However, our JHC grant, the one that we're reporting on here, really has had a significant effort over the years devoted to USVs. And we focus on what we try to call practical autonomy, safe, efficient, effective operation of autonomous vehicles for our purposes. And I think Val, who leads up this effort for us, has written a really, really nice paper in the International Hydrographic Review on best practices. And if you're interested, I'd encourage you to take a look at that. You see here some of our suite of autonomous systems that we looked at. This past year, we just finished up a major exercise in Thunder Bay, Ontario, supporting several NOAA groups and the Ocean Exploration Trust, and that was with our 4-meter ASV we call Ben. And this is a different mode of operation. Here we're using a shore-based control center and send it out each day from the shore-based control center, a command center. And so we've had lots of experience now doing this and working in this mode. We have optimized our tools for situational awareness, the ability to respond quickly to unexpected situations, which always seem to arise. And we are continuing as we go along the development of our raw space, our remote operating system based backseat driving tools, looking at the trade-offs between overload of the operator and the information you need for full situational awareness. One of the things we're very proud of is our CCOM Autonomous Mission Planner, or CAMP, a very effective tool for mission planning, and most importantly, for being able to implement on-the-fly changes as things happen, and things always do happen, particularly in a place like this where there's so much traffic in the Great Lakes. One of the things we've learned and been very, I guess I say, constrained by is the tremendous differences we find in the ranges of the telemetry systems. And we're using probably the best telemetry systems we can, but we found that they're very dependent. The ranges are very dependent on both weather and sea state. And so this year we implemented a very effective means of extending that range by being able to change on the fly from our shore-based control to control from a support vessel, which was out there anyway. And this greatly extended the range. So, some days we're getting 10 kilometers range, some days we're getting 20 kilometers range. But if we're out there working and suddenly find we're at the limit, we just switch on the fly over to our support vessel and it can take over and then greatly extend our range. And so this is something that we see has many, many possibilities for future modes of operation. So the group has also been doing a lot of software development. Our mission planner, I mentioned, the development of a new winch. This is not quite software, but software and hardware, winch and CTD system for the vehicle. The implementation of a parallel redundancy planner, which will hopefully maintain control through many telemetry loss situations. And our continued development of what they kept calling Project 11. I said, that sounded so secretive, and I was so excited about where'd they get Project 11 from? And then I realized that as we had listed the tasks through the proposal, this happened to be task 11. So that's what Project 11 means. But this is the software backbone for the systems aboard the vessel and for our situational awareness activities. And again, I want to emphasize that using the ROS operating system, what we develop on any one of the platforms is easily transferable over to other platforms. And we'll be experimenting that with the implementation of the DRIX in the coming month to see how easy it is to transport these activities over there. One thing we're really proud of is that with respect to situational awareness, our team entered an international virtual ocean robotics challenge where they had to operate in a simulated environment, which was in the Spezia, Italy. Excuse me, operate an uncrewed system and identify targets, react to those targets all autonomously, and 13 very, very impressive entrants. But I'm very proud to say our team won first prize. So hopefully some of the things they're doing that will get implemented into our situational awareness exercises will indeed be based on this situational awareness and excuse me, machine learning and artificial intelligence approach. Oh, catch my breath there. Okay, I mentioned that just excuse me, a few days ago. A new DRIX arrived. It's being unpacked now. Otherwise, I would have Val here showing you what's going on, but it's being unpacked, put back together, commissioned. This is through the Cooperative Institute and Ocean Exploration funding. But again, lots of the tools and that we developed under the Joint Hydrographic Center grant will be ported into this. I said they're busy unpacking it, getting ready for the month of July, which will basically focus into early August on a series of sea trials and commissioning. And once that's done, the vessel will be sent to San Pedro, where it'll be integrated onto the exploration vehicle Nautilus, and then the beginning of our ocean exploration programs, OECI programs, which are going to focus on collaborative operations between multiple vehicles, between autonomous underwater vehicles and ROVs. And we have a whole series of steps planned to make that more and more sophisticated in terms of the communication and collaboration between vehicles. I want to throw out something that if those of you around a number of years ago may have seen, maybe not, but it's an idea we've had kicking around for a long time as a way to increase efficiency, we think quite simply, and that's the idea of multiple towed multi-beams behind a single launch, greatly increasing the swath width. We were just kind of talking about that a long time, but fortunately our vessel captain, Matt Rowell, is a very talented mechanical engineer, and so he's now designed a prototype, and hopefully in the context of the new grant, we'll push forward on that. And certainly if any of our partners are interested, we'd love to talk to you about this. Still, along the theme of data collection, we have looked into trusted community bathymetry, and this is under the leadership of Brian Calder, and they've got this intriguing project of integrating a low-cost side scan with a low-cost commercial data logger. And the system is designed to autonomously record targets in a given region, convert that into an XTF format, and then be able to render it into a variety of hydrographic software applications. Well, this is nice, but if you look at the logger they're using here, they cost on the order of $250 each. And we start talking about a logger alone, that's $250 each. The idea of a huge crowd that everybody can supply data with becomes a little concerning. And this is why Brian likes to call what we're getting volunteered bathymetric information, because we don't really have that huge crowd yet. So Brian has been thinking about how we can build that crowd. And one part of that has to be a very low cost collection system. And there has to also be a concept of operations. And so Brian, with a team of undergraduate engineering students, have been working on both the concept of operations, as you can see here, and also involving cloud services. And most intriguingly, they've been building and have built a very inexpensive data logger. It's not just built, it's working and logging data. And we see the price of this for batches of 5 is about $15, batches of 50, less than $8. And when we start talking about prices like that, then we can really think about just giving these away to everybody. And we may really see a crowd built up. Once we start collecting crowdsourced bathymetry, we have to worry about its quality and how do we test that. Brian and graduate student Shannon Hoy have been looking at that. They've been looking at ways of identifying predictable problems with the data, outliers, things like that, and have found solutions to the ones here in green. There are still areas where they haven't yet found the solution, but are working on it. Most intriguingly, what they have been looking at is a way to qualify the data, to determine the reputation of the data, and you do that by comparing it to qualified data sets. So you have a crowd coming through an area where you have a reference surface of some sort, and by judging the crowd's data against the reference data, you can offer a reputation of the data from the crowd, and then weight the data with that reputation. They'll be working on these further solutions, and at the end of the day, the plan is to use multiple approaches in machine learning with a fusion solution to converge on the best answer, and hopefully we'll be making good progress there. We've talked in the past, as we now switch from data collection to data processing, of the evolution of cube to chart, the cube with hierarchical resolution techniques, and Brian's work there. And we've talked about the level of aggregation approach that's been built into that now. And in this past year, the focus has been on the development of a distributed computing approach for chart and a specific implementation with QPS Fleet Mouse. Along the data processing line, we come back again to our collaboration with Coast Survey in the development of HydroOffice, which also has a series of survey and chart validation tools that are built in. And this year we've improved several of them, something called Feature Scan, SBDare. We have a tool now that does validate tools for bag files, and at the request of the Canadian Hydrographic Service, command line approach to ease the workflow integration. We have also extended our automated processing tools to LiDAR systems, and working with Chris Parrish at Oregon State University. Brian and Kim Lowell have built what we call C-Blue, a comprehensive bathymetric LiDAR uncertainty estimator. This is, again, a rather mature tool. It's been used in the fleet for some time to attribute uncertainty to LiDAR data. And this past year, it has been upgraded to include the Leica Hawkeye 4X. And we've also taken ownership of the maintenance of it, of the GitHub repository from the NOAA IT office. And as I explained yesterday, you guys probably would understand even more that if you're wondering why we took over ownership from the NOAA IT office, you probably have not had experience working with a government IT group. It just became impossible. So we just took the ownership of that over and make it much, much simpler to interact with. Oh, excuse me. Last year, we introduced the concept of using machine learning and basically a chart-based approach to bathytopo LiDAR data. And we showed some very, very good results of being able to, through the machine learning, identify what was real and not real bathymetry. The bathytopo LiDAR data is inherently noisy. It's a big challenge to do that. And we were very happy. And that was done just on a couple of tiles before our presentations. And then Brian and Kim started to expand that to look at much, much more data and found that the approach actually failed in situations where there were reefs or shallow channels. And so they literally went back to the drawing board and have come up with a new approach, a new machine learning method using unsupervised k-means clustering with disambiguation rules. And now looking at large data sets, they're seeing a very good agreement. So we're hoping that we really are converging on a robust machine learning approach to Bathy topo LiDAR processing. We have, or will with, I should say, the new grant. We've just started this, start looking at ISAT-2 data. We think there's tremendous potential in there for aiding our bathymetric and remote sense studies. And so again, this is something we're just starting up, learning how to handle, manipulate the data and seeing what the constraints will be with that in terms of the capabilities over the coming years. We're going to move now from data processing to our seafloor characterization, habitat, and resource mapping tools theme. And here we're both looking at the seafloor and the water column. And in terms of that broader context of characterization, we have had a lot of effort, Tom Weber, Liz Widener, Alex Padilla, focusing on the full understanding of what we're seeing in the water column. They've done some remarkable work in terms of a much better understanding of the nature from a theoretical approach of what we're seeing in terms of midwater reflections. We've seen things that are representing all kinds of interesting dynamic oceanography, and they are now actually looking at the nature of that layering, what we can resolve and what we can't resolve, and trying to come up with a theoretical base so that we can do that inversion and really extract as much information as we can out of it. We think there's potentially a great directions we can go there in terms of extracting further information. Yesterday, Liz gave a beautiful in-depth description of all this. Tom and Alex Padilla have also had the opportunity to deploy a long-term observatory, acoustic observatory on a natural seep field at Platform Holly on the West Coast. And they've now been able to collect months and months of data in sonifying a natural seep, looking at the natural variability of that seep and what's going on in terms of the type of effusion of sometimes bubble clouds, sometimes individual bubbles. And they're looking now at ways of unraveling these data and trying to get to estimates of flux and flow rate. That again will be very helpful in other further applications. When we move our characterization efforts down to the seafloor, I think I've told you in the past years of the work of Giuseppe Massetti in the development of the BREST tool. This is a tool that extracts what we call geomorphons or characteristic morphological features from the seafloor automatically. Larry Ward has taken these tools and developed other protocols for the analysis of both multi-beam backscatter and multi-beam bathymetry for the specific purpose of the identification of sand and gravel resources, and in our case, in the Gulf of Maine. And again, hopefully this fits very nicely into our new theme of blue economy and resource mapping. On a much broader scale, under our theme of Explore the Continental Shelf, Derek Sowers, for his PhD thesis, used the data we collected in support of the extended continental shelf on the entire Atlantic margin to produce a consistent and reproducible habitat characterization map for a good portion of the Atlantic. And this is, I think, really the first time this has been done at this scale. Even more exciting, if we zoom in a little, on a regional basis, in this case, the Blake Plateau, Derek was able to use the same approach of identifying geomorphons, in this case, ones that appear to represent the occurrence of cold water corals, mapping what's likely the largest cold water coral province ever discovered, and providing input to the South Atlantic Fishery Management Council. And so we're very excited about that too. Zooming in again down to a finer scale, Jen Dykstra and Kristen Mello have been using ground truth ROV video data from the Okeanos Explorer to look at the relationship of the distribution of various species to both morphology and environmental factors. And so we're going from the entire margin down to a region, down to a small little area of seamounts and canyons. Jen Dykstra and Chris Parrish have also been looking at the potential of using LiDAR returns to discriminate the roughness of the seafloor rugosity, and potentially use that then to look at the changes in the health of coral reefs. And they're just heading down to South Florida to look at that now. Yesterday, when we had our in-depth, just a few in-depth presentations, we had a wonderful one from Christos Kastriosis. And Christos is our cartographer in residence, and we're happy he's there because it's a new direction for us moving into cartography. And Christos has really been upgrading a bunch of what we do into the world of electronic cartography and automated cartography. And so he has been very active on a number of cartographic fronts, developing tools for hydrographic sounding selection, for sounding selection validation, for cartographic sounding selection, for working with Colin Ware, depth uncertainty visualization, for looking at data quality, polygon simplification, and many, many others. And again, if you're interested in these cartographic applications, I encourage you to either go to our progress report where you can see a lot more detail on that, or get in contact with Christos himself, or again, Brian or I will put you directly in contact with him. Another thing he talked about yesterday is something we're very excited about, and that's some formal collaborations we're going to have with the Maritime Academies, because as we start developing these tools, as we start developing some of the visualization tools that I'll talk about in a moment, we want to make sure we're really testing them all the time with real mariners. Brianna Sullivan from our lab has continued her efforts for looking at ways of mining textual information. I always trip up on that word. I want to say textural, but it's textual, actually going to looking at documents, printed documents, and extracting that text and putting them into a digital world. And she's been working closely with the IHO NIPWIG, the Nautical Information Provision Working Group, on the development of new S100 products for marine harbor infrastructure. And this involves compiling the information, converting it to a unified modeling language, and then converting that to a geographic markup language, so it can then be put into an ENC. And they're slowly working through this development cycle. I think they have already something like 51 features identified. I mentioned about the transit of the sail drone to Hawaii. We did the planning for that with a really exciting new tool that Colin Ware has developed called Gap Filler. This is a tool that has our latest compilation of existing data, in this case, the JEBCO 2021 database in the background. It lets you put in a start point and an end point, or a bunch of waypoints in between if you want. It'll instantly give you the great circle route to get from point A to point B. But then you can start zooming in. And I should say we have both Mercator and Polar Stereographic, because we're about to go on a Northwest Pacific transit that we're using this for. It'll give you that basic great circle route, as you see here for our route to Hawaii. You can then, in the context of the existing data, start moving that, planning your optimal route to fill gaps or butt against lines. But the beautiful thing of this is it uses the database that the Multi-Beam Advisory Committee has on existing systems. So you plug your system in and it'll have a table of what kind of coverage that system gets in a particular water depth. It will then plot out the expected coverage, so you can change how much you want to overlap or not. You can design your survey knowing what you'd expect in terms of coverage. And if you design a standard modal lawn type survey, it'll do all that automatically at your expected overlap or desired overlap. That's a variable you can change, and it'll come out very quickly with a table of the time it'll take you to do it, the amount of overlap, and in our case, the amount of new ground covered, which is a very important statistic that we're looking at. So I said we use that for Hawaii. Other people have been using it, I think, quite successfully, and we'll be using that for our Northwest Passage transit coming up this summer. As we move into our visualization world, which is still within our transforming charting and navigation programmatic priority, we look to the future of navigation. Tom Butkowitz and his team in the Viz Lab looking into the power of augmented reality to support navigation. Of course, this is something you really want to be in the lab to experience, but we'll try to give you a little glimpse of it here. In the past, they've been constrained, and I think we've talked about that, by the limited ability of the existing augmented reality goggles to work in daylight conditions. They just weren't bright enough. Well, Tom has found a new one, something called InReal, that is a very small, lightweight device, has very good daylight visibility, and as you can see, is very, very stylish. And I hope it comes in a variety of colors to go with whatever you're wearing that day. What the team has been doing is looking at approaches for the real-time display of LiDAR point clouds. Here we are looking at the Crescent City Bridge in New Orleans, so that in situations of low visibility, the observer can actually see the structure georeferenced. It's a huge challenge to render hundreds of millions of points quickly while georeferencing it, but they're really gaining quite quickly on it. At the same time, they've also put a lot of effort into bringing bathymetry, including bag files, bringing flow data, and bringing LiDAR LAS files directly into the Unity 3D graphics engine. And the Unity 3D graphics engine is probably the most common graphics engine out there, and that offers a range of opportunities for display on many platforms. Here again, we have a flight along the Mississippi River shoreline around New Orleans. Again, hundreds of millions of points. It's now being displayed just strictly on a river or sea level here. We're waiting to get from NOAA the bathymetry, and we'll then mask the bathymetry in there, and you'll have the continuous picture of the bathymetry into the shoreline. I think we showed you last year, or maybe 2 years ago, if you were able to visit the lab, people have put the glasses on and seen this combination of both virtual reality and augmented reality reconstruction that is from structure, from motion. And we talked about our ability to annotate the image in the 3D environment. So with this little augmented reality device, you can annotate, measure, and so on. Well, this year that's been extended so that the annotation can be done directly on the 3D model just once, and then automatically propagated back. And you can see all the propagations back here, excuse me, to the thousands of video frames that can then be rendered or re-rendered from any viewpoint showing the annotations. And this allows machine learning algorithms to learn how each object will appear from many, many different angles, many, many different points of view. And it really should promote a very robust machine learning identification process. So we're very, very excited about carrying this to the next step. We have a data management mandate, and that's under the direction of Paul Johnson. And I encourage you to go visit our map server website, maps.ccom.unh.edu. There are a number of map services on there for a number of databases, our Law of the Sea data, the Western Gulf of Maine, the Western Gulf of Mexico, the US Northeast, many, many more. And really beautiful places to look at data and to interact with data and to extract data. Paul's also built a nice collaborative tool for looking at the quality of data. You can mark up areas where you think there are problems, and people can work collaboratively on that. Most recently, he's built a beautiful interactive web viewer for exploring JEBCO bathymetry, for the new JEBCO 2021 bathymetry, and as we update it each year. And so really a beautiful way to visualize it, to look at it, and then explore it in 3D. So again, I encourage you to go to the website for that. We have, and I think you've followed this probably with great interest over the years, been trying to really understand the radiation patterns of multi-beam sonar, of the multi-beam sonars that we use. This is not an easy thing to do for a deep water multi-beam, but we have been very fortunate to get access several times to the Navy hydrophone array off San Clemente. And there we have been able to bring our systems, bring EM-122 several times to that hydrophone array. And Mike Smith, one of our new young researchers, has been really hard at work trying to unravel these complex data sets, and they're very, very complex. And he's now made great progress and can now measure and visualize metrics like the peak sound pressure and the power spectral density through different modes of the sonar operation. And he's created, and I got to start these up by hand, I don't know why they don't start automatically. He's created some beautiful visualization tools that allow us to look at the spatial and temporal variability of the received signal of the multibeam sonar as it moves through the array. And by being able to look at this all at once, we're being to really understand and compare the kind of theoretical models that folks like our friend Xavier Lerton have created to what the systems are really doing. This has been very helpful and very educational to us. At the same time, in parallel to this, and we introduced this, I think, the last 2 years, Hilary Cates Garkesi and Jen Mixes Oles have been looking at the impact of multibeam, that the multibeam sonars have on a resident population of Cuvier-beaked whales. And these are very sensitive whales that happen to live at the range. We reported previously on Hilary's analysis of the temporal behavior of the whales during the survey, and a paper that was recently published showing that the multibeam sonar did not appear to have an impact on the foraging behavior of the whales. That's the temporal behavior. She's now turned to the spatial behavior. What have they done in terms of where they move to? And in that, they've been looking at a global local comparison method to analyze that spatial behavior. They've got a paper on that methodology that's just come out, and a paper on the results of the analysis, which again appears to show no change in foraging behavior that's related to the multibeam sonar, is currently under review. So we're very excited about that. This no more anecdotal information. We now have some really, I think, very careful studies that are demonstrating, in this case, the apparent lack of an impact on the foraging behavior. That's all we can say of these whales. But certainly when we looked at the impact of things like, or when papers were published about the impact of Navy sonars, we saw a tremendous impact on that same foraging behavior in the same place using the same methodology. So we're very confident in terms of what we're seeing. Finally, we understand that at the end of the day, we serve the public and we have an obligation to inform the public about our activities and where we can to engage the public. And so we try to maintain a number of outreach efforts. Normally we bring thousands of students and others to the lab. We have ocean discovery days and things like that, but obviously COVID has presented that. So we've had a focus, of course, on our websites and our social media, and those are supported very, very nicely. I think I don't know how to judge these number of followers, but the numbers always impress me. We've done what we can. Tara and her team have actually run some virtual sea perch trials, and we are slowly now bringing school children into the lab. And hopefully with that marking the end of this, what Queen Elizabeth called years ago, Anno Horribilis, this terrible, terrible year. And hopefully we'll start bringing our own people back into the lab. We're still not fully open. And hopefully things will start returning to normal. And most hopefully we'll be able to bring you all back to visit us next year, to have our real interaction with NOAA and really do what this is all about. With that, I come to an end, except to prevent Harold from interrupting me. I do want to present in my last slide a public service announcement. And Harold, you chime in now and you say what you want about the upcoming Hydro 2021 conference. Harold, do you want to say something?
Sure. I got it. I got the microphone going. So I want to welcome everyone to the to register to take a look at our website for the U.S. Hydro conference we're holding virtually September 13th to 16th. It was a decision we had to make. We thought we can get to Wilmington, and we had to cancel the in-person event. I know that a lot of folks were looking forward to an in-person, but it was just something that we didn't feel comfortable doing. So we have over 60 abstracts submitted. We're going through the review now. We're going to have, it's over 4 days. We have the first day, which is going to be, a workshop with the vendors. There's going to be exhibitors, but not really exhibit booths. There's going to be information out. So it'll be an interesting thing. The tentative schedule is posted on our website. Registration is open. So just feel free to check it out. If there's any questions, just contact anyone of us at THSOA. That's all I got.
Well, thank you, Harold. And I'm going to apologize ahead of time that a large number of us in the lab are actually going to be just coming into Nuuk, Greenland on the 13th of September and struggling to get back. We were hoping we were going to be able to get back to, and we're not sure about what kind of bandwidth we're going to have from there. So I know we've submitted some abstracts, and there'll always be somebody there, but I apologize ahead of time that some of us will just be out of touch at that point. Let me stop the share so we can at least try to get as many people as we can on the screen. And again, let me apologize for running a mile a minute. We wanted to just give you a feel for what we're up to. Again, not enough detail for you to really understand too much about how we're doing any of that. But again, any of those things that resonate with you, we're happy to talk more about it at any time. Send an email, send a fax, send a telex, send a letter in the mail, whatever you want. And we're happy to discuss more. But we do now have, a good 45 minutes or so at least to go into more detail in terms of questions that you might have. Did I? No, I bet you I just shut you all off. Did I shut you all off? Is anybody out there? No,
We're still
you're
here.
still there.
Oh, we're still here, Larry.
Oh, good. Whoa, my screen went away for a second, but there. Okay, I see you all back. Okay.
Larry, Guy had a question early on about.
Okay, yeah, and I said I apologize. As I was running a mile a minute, I wasn't keeping track of the chat. So now, if there are questions in the chat and things like that, let's. Here we go. Go ahead.
So yeah, I put one in the chat, and specifically about that chain calibration method. It's very interesting. The couple questions: does it have to be recalibrated for different kind of water masses? Like if you were. And then over time, I'm expecting that this could be used as a long-term trend mechanism for the degradation of the transducers.
Yeah. Okay. So, and I don't know if Tom Weber is on. I know Tom is in the midst of a World Series, a baseball World Series.
I'm
Oh,
here.
he's here. Okay.
Yeah.
So let me. I was going to answer those questions, but it's much better if you
Go
do.
for it.
No.
Oh.
Well, you'll just correct me, so I'll save the embarrassment.
Oh, that's half my fun. So that's a great question. We only use the chain target in our tank. We've kind of kicked around the idea of trying to use it as an at sea kind of calibration, but I think the mechanics of that, it's a somewhat delicate piece of chain. If you've ever seen it in person, or maybe next year when you're here, you can come check it out. So it's really meant just for use in our tank to replace sort of the longer week-long kind of calibrations that we do. In terms of using it for long-term degradation, that is a great question. And we don't, I think as a community, have a ton of data on those type of things. I know there's a few kind of things that have been done somewhat anecdotally here and there where, people have discovered by going over the same piece of seafloor and seeing a dramatic response in the seafloor that they actually have a problem with, or a problem has arisen with their transducer. But in terms of the sort of subtle year-to-year change in the sensitivity of the transducer arrays or the system in some other way, we definitely could do that. We'd have to bring the system into the tank, but that is an issue to be addressed for sure. What the best way to do that is, I'm not 100% sure, but it's something to think about, no doubt.
Yeah, that's kind of the way I would answer too. That I think from the water, we only do, as Tom said, we've only done this in our tank. I would think that different water masses would have an impact, and I suspect it would be rather small though, Tom. But I think this idea of using it as a way to look at degradations of a system is very clever. I think one of the things we would need to do, Tom, comment is kind of do that calibration over a long period of time and see what kind of variability we get. If we just look at the chain over 2 weeks or so, what do we get in terms of variability? And that would constrain how well we can do the best. And I'm going to ask, there's some kind of background noise, so I'm going to ask if everybody can mute who's not speaking. Thank you.
I don't know if that background noise was me or not, but the Mashkor Malik might have done some of that long-term stuff. He was doing work with multibeam in the tank, and I'm not sure how long in time he got, but he might have gotten up to to a couple of weeks. But just one other comment in terms of the different water masses. There is, I think it's Dave Deemer from the NOAA Fisheries at the Southwest Fishery Science Center has a paper looking at the response of transducers as the temperature and salinity change. And so, it's not a huge effect, but it's important enough that the way in which, for the fisheries echo sounders, when we do the standard sphere calibrations, the rule of thumb is to do it in every different water mass you go to. I'm not off the top of my head, not sure if that's a 3 dB difference or a 2 dB difference or a 1 dB difference. It's not huge, but it is there.
Yeah, and I'll follow up with Mashkor's stuff because he did as part of his thesis. He didn't look at the chain, he looked at the wall, the tank wall, and he did look at it for several weeks. I mean, probably 3-4 weeks, and it was insignificant in terms of the change from the wall. So that was looking at the instrument itself. So the sonar itself was less than a dB in terms of variability. I just wondered about the chain itself, Tom, that the chain is free to kind of flutter a little, and how much variability the chain might count for. And I also might make the comment that Dave Deemer could do that because he's got the $1 billion tank that he can change temperature and salinity and do all kinds of amazing things out there at the Southwest Fishery Centers with. We're very jealous. We're very jealous about that tank.
Yep.
Got some questions in the chat related to the chain from Matthew Zimmerman.
Maybe Tom can't see it, so I'll read. Have you been able to replicate the results of with more than one chain? I think we've only used one chain. Can the chain be calibrated enough to make it chain agnostic? I like that. Would it be possible to have a process for calibrating multiple chains so that in future tests, the same chain would not be required? So Tom, I'd toss that over to you too. Or I'll make up an answer.
Well, I think, like you said, we only have the one chain target. I think it was so tedious to construct that it's sort of graduate student abuse to make someone make another one. So we've only used that one chain, and really the basic principle behind the chain is actually that you said flutter, or it's built of little tiny scatterers that are each random from each other. So you could use different size chains, or you could try to take the same chain and build it anew. And as long as you use the same chain lengths and kept the sort of the aerial density, the number of links per square meter or something like that, the same, you'd probably get something similar. But the way we use it is that we calibrate the chain target itself. So we translate the calibration from a standard sphere target that we feel is an absolute calibration. We calibrate a relatively simple system with that, and then translate that to the chain target itself, so that that chain target becomes relatively calibrated. And that's the mode. And I'm not sure that I would ever try to push too much further to say that if you have this specific type of chain link, that you're going to know just from first principles that this is what the target strength is.
And Tom, I'm trying to remember how much time it took. Was it a couple of weeks to calibrate the chain itself?
No, it's quite fast.
Okay, good.
So,
right. So it seems to me that anybody can build a chain and have that relative calibration against an absolute calibration. You don't have to use our chain. You can use another chain. It's a concept that you've now taken something, and instead of having to do the really complicated process of the sphere calibration, which does take a long time, you now can calibrate a chain. I guess you need a tank too to do it. To try to do it offshore somehow might be real difficult.
Yeah, and just to remind everyone, the underlying principle there is that it's an extended surface target like the seabed. As you said, it's in your earlier slides, it's an analog for the seabed. And I think one way in which we're looking at it is, if we better be able to get the calibration for the chain target right, if we ever expect, in that kind of simplified sense, if it's like the seabed, if we can't get the chain target calibration right, then we're in trouble on the seabed itself, which is even harder, right? So that's kind of what we're thinking about these days with that chain target.
Right, but I think that the key, coming back to Matthew's questions, is that there's nothing magic. I mean, the chain, as you say, it's a lot of small scatterers, but there's nothing, this wasn't $1 million special chain target. This was just some material that had this characteristic. Anybody could build something like that. And so you don't have to move our chain around from one place to another.
That's right. The expense of the chain is pretty minimal. Yep. It's easy stuff straight out of McMaster Carr or something like that. Yep.
So Tom, did you use standard target and then projected that onto the chain? And have you tried that simultaneously with a pulse length gap between the chain and the standard target and moved the transducer around the chain? Have you done that?
You mean have both targets at the same time?
Yeah.
No, we haven't. What we do is we use the standard target to calibrate the EK system and then shoot the EK system at the standard target. And so we go that path, basically.
And then you're doing this horizontally?
Yeah, we do it actually. So we look at, so the chain target is basically, it's 2 meters by 2 meter surface. And we look at it mostly perpendicular to that, but we do actually look at the angle dependence of that target too. So we shoot horizontally at the chain target, but then subtly, over plus or minus 65 or 70 degrees, rotate the chain target to get the angle dependence, which is actually, it's pretty flat. It doesn't have much of an angle dependence at all, if any.
Would you be concerned about bringing it down in the field and biofouling on the chain over a long period of time?
Yeah, well, our particular chain target, I think, just it's too delicate probably to use anywhere other than the tank. I think it would just fall apart basically. But you could over time, yes, there would be a major biofouling problem, but you could construct something that was a bit more robust and put that out there.
So Tom, I mean, I think this is kind of tied into everything we've said in a sense. If we had a beautiful patch of gravel on the seafloor, I mean, it's that we magically knew was not going to move and not going to change, it should do the same thing.
Absolutely. And I think this is what underpins the whole idea that John and Miguel have and are working on. So they're following exactly the same path. It's just that they're using the seabed, like you said. And as you say, if you can find a piece of seabed, a piece of gravel and the middle of some channel that's always being swept clean or something like that and not changing, that seems like a good thing to use year after year after year to look at long-term degradation or whatever else as well. Getting back to Guy Knowles' original question.
I might interrupt for a moment. One of the goals, this is Larry Ward, in the new program, the new grant, that one of the things we're trying to do is develop reference sites that will include a gravel bottom and some of those standards that we can use over long periods of time.
Yeah, so Lindsay wants to extend this now to deeper water. Any way for taking from this tank into operations for deep water systems, we'd have a brief discussion with Tom about direct EK observations of the seabed from ROV.
Yeah, we'd had some, sorry, Larry. Yeah, we'd had some discussion with Tom about that. Instead of trying to take the chain out of the loop for the immediate sort of calibration, just take a EK down on the ROV to anywhere you want, really, and try and take the observation directly. That doesn't account for the long-term changes, but it might be the immediate comparison of the between the EK and then the multi-beam, because you have it right there.
Yeah, I guess I'd rather see basically, again, use the seafloor in a place that you have some confidence. That's the key. It's finding a place you have some confidence is going to be non-changing, and
Yeah.
use the cross-reference of the calibrated sonar looking down at the seafloor versus the multi-beam looking at the same seafloor.
Yeah,
No, I think we all agree with that. And I think what Lindsay's saying is that in order to do the deep water system that has a near field that goes out hundreds of meters, you have to be in the deep water. So you might be bringing the the calibrated EK system down, transferring its calibration to the seafloor. But the question is, what's the platform? Is it going to be on an ROV? Is it going to be on something else? It could be on a pole mount, actually, if you're not too deep. So something like that. But I think, yeah, Larry, I think you're exactly right about using the seabed, not the chain target at sea.
Yeah, but using the ROV, you'd be limited on size of the transducer, therefore frequency. So low, frequency 38 and lower would be very difficult.
Okay, I see Val has joined us. You might have been there all the time for all I know. Do you want to just turn your camera around and show them the Drix being set up there?
You bet. It's a little loud in here because it's hot. We got a fan running, and we're in a place at the university called the Olson Center for Advanced Manufacturing. And if you ever get a chance to come visit this, when you come visit us, you definitely should. There's all kinds of robotic arms and 3D printers and milling machines and all kinds of advanced construction stuff. But we've carved out a space in here for sort of a second ASV lab.
Val, let me interrupt you for a second to say that this is just one, where Val is now is just one small part of this space. There's 680,000 square feet. I'm not exaggerating.
Yeah.
Of empty warehouse space there.
Yeah, it's a gold mine that the university will probably blow somehow, but yeah, there's a ton of warehouse space behind that wall that would be great for all kinds of massive projects with big high ceilings and compressed air and all kinds of power. And anyhow,
and a trolley system in the ceilings.
Yeah. So this is Drix Hall 8 in its docking system, which is called the universal docking system. And maybe you can see there's some stuff going on, but maybe you can see like the bow here and how narrow it is. It's probably less than a meter wide and something like 7.7 meters long. So very narrow hull form with a wave piercing bow that maybe you can see it kind of behind there. And the gondola, where all the business end of things are from sonar perspective, is down here. It's fully retracted now, but fully extended is 2 meters down. And we've been going through a week's worth of training, crawling all over the thing, learning the nuts and bolts and what works and what doesn't, and going through an acceptance process. And we'll do another week next week, hopefully at sea, starting on Monday. And if all goes well, some sonar tests later in the month and into August. And then we'll take a break because we'll be tired. And then we'll ship it to the West Coast to go to sea for the first time. So yeah, very unique hull form, very fast, 12, 13 knots, something like that. I think they say, we'll see if this is true. They say 7 knots for 7 24-hour days, which is a pretty nice endurance for a boat this size. Of course, the devil's in the details, and that's what we're trying to sort through. I'm happy to field any questions to the extent that I can.
Thank you, Val. So questions to Val, questions for anybody, any of our folks who want to chime in about things? Again, I always ask them to say what I said wrong, to correct what I said wrong. Nothing out there? Okay, well, let me then throw out a question for you. Let's start with things that you didn't hear that you were hoping to hear that we might be doing that might be of help to you.
Hey, Larry, this is Bridget.
Oh, Bridget, yeah. Hi.
Yeah, good to see you again. Thanks for that presentation. You went through a lot of stuff very nicely. It was
very quickly. I apologize.
No, it was great. Something that you touched on that I'd love to hear more about. I mean, Bedrock is kind of forming this end-to-end solution, and something that we're thinking a lot about is how to make ocean data free and easy for people to touch. And I was wondering, beyond what's going on in Brian's group, which is awesome, how you guys are generally thinking about data downloads across different organizations. There's all these different tools for that right now. Is that something you're thinking about in the coming years, about how to unify this into a single system?
Yeah, that's a great question. And certainly it's something we think about quite a bit particularly because we deal with so many different entities. And everybody is pushing us into the cloud, which is perfectly sensible. I think you'll see Weatherby is somewhere in this array here, and we've been working with his group in terms of looking at a range of cloud solutions. Our Seabed 2030 activities have been looking at cloud solutions, and it's all coming. I shouldn't say coming together. It's all coming at us, but hasn't come together yet. And so I'm gonna defer to Brian to say something about where he thinks the future might be, and maybe we'll hear from Weatherby too, because I think Weatherby probably is the closest to this of many of us, and maybe Guy might want to say something too from an Esri perspective. But Brian, go ahead.
I think I would prefer that the data not be downloaded, frankly. Once we upload it, it should stay there. And what we'd end up downloading would be something that we derive from that data, which is typically very much smaller. One of the major, as I'm sure you're very well aware, one of the major costs in being involved with the cloud-based system is getting data out of the cloud. And so I think what we're looking at in terms of our development priorities is to make sure that what we are developing also follows the data into the cloud. So that instead of the data following the processing, which has been our case for the last at least 20 years of my experience, we really want to have the processing follow the data instead.
And I'll make a comment too, and then we'll turn to some of our other industrial partners. And I kind of alluded to it when I talked about what was happening with the GitHub repository and pulling it away from NOAA IT. I think one of the biggest roadblocks we're all going to run into, because inevitably the current data repositories are mostly government held. And I think there's going to be tough bridges to cross to basically have that free, not that the government is reticent to share data, that it's one of their mandates. It's just sometimes the constraints about getting access to their systems. And I think we'll all have to learn how this evolves in the cloud. Will that all be transparent? Maybe that'll be one of the greatest blessings of the cloud, is that kind of will go away. But right now, I think we're still suffering a bit from those kinds of roadblocks. Weatherby?
No are making progress on that though, Larry. I think we should be encouraging of that. NCEI, for example, are setting up point stores for some of the data now, and in the cloud world, and I suspect they'll probably try and follow that as long as their first foray into that is successful. Although it's true to say that the particularly security requirements surrounding federal IT does tend to make it a little bit difficult to work in that space.
I think one of the things that we're focused on in this current Azure implementation I'm working on with Paul and Ryan and Larry is exactly what Brian said, and that is, make sure that the derived results can be published as web services that are RESTful, that are easy to consume in any other tool, and that you get, metadata that's tied down to the pixel level, to understand what file that came from and have that linkage. So sort of using best practices to structure this and building a portal in Azure that'll be linked with UNA, with CCOM's on-premise portal or ArcGIS Online, and will allow a lot of experimentation to occur and web services to be consumed by various projects, and cloud-based, editing is part of that, of course, cleaning data and whatever else people are interested in.
Thanks, Guy, or anybody else who's had experience with this? This is kind of a new world for a lot of us, but it's a very exciting one.
I just posted a couple of links, Larry, in the chat. There was a demo that earlier this week by the Forest Service information folks who have done some really innovative work using, I think it was the Azure, might have been Amazon, I can't remember. Just minor differences between the two. Putting terabytes of imagery in the cloud and then doing their analytics in a protected space we don't have any input. We don't have to translate it. We don't own it. It's very different from the Google licensing, the Google Earth licensing. They get access to your algorithms. We don't have access to the Forest Service algorithms, but we give them the space and then they work on that. And they then publish information out of that they use to make, very critical decisions for the management of the forests. So it's an 11-minute video. It's pretty interesting.
Thanks. Any other experience that somebody wants to share with that? Don't be shy. We're all friends here. Ha. Okay, other questions, concerns? Again, places you'd like to see us delve into. Can't guarantee we'll do it, of course, but only Noah can insist that we do it. But usually if you're interested, they should be interested too. Silence, amazing. So we're doing everything perfectly. So that was the question about things you want us to do. There's obviously nothing. Uni, I think Uni, you were going to say something there, I guess. No, this is much harder than in person drawing people out. I gotta tell you. Where's Doug? Tell us about your construction. The people I can always count on to say something. It's too easy to hide in this world.
Well, I do have a bit of a comment, and this is way out in left field. So I still keep an eye on my LinkedIn account, and for years I've been watching all the images that people post to their multi-beam data, and the vast majority are of shipwrecks. People like to show shipwrecks, and I've been trying to. That's always struck me as odd, because I tend to see those as just old junk we left on the seafloor. And I think what's vastly more interesting about what's in the ocean is, well, the ocean itself, the biology, the geology, all of the stuff that's not our old stuff we left behind. And that stuff is in fact far more important to us as a species and to our planet. And I'm wondering if maybe there's a way to focus some of the amazing stuff you guys have done with graphics into a broader outreach that could get larger segments of the population excited about the ocean for what it is, and not just the old stuff we've left behind over the years.
Yeah, that's it's a something I think many of us thought about for a long time. You're absolutely right about people always being intrigued by shipwrecks. I think there's a fairly straightforward explanation. You show people seamounts and other things, and I often have to spend a lot of time, even with our beautiful 3D renderings of them, explaining what it is. You show them something they recognize, like shipwreck, and right away they, oh my gosh, they can see the bow, they can see the stern, they can, so I understand that, but I think we've been, and particularly in the Seabed 2030 world, we're really trying to encourage the entire world to contribute to mapping all the unmapped parts. We face that exact challenge of how do we, I mean, it's a question I've often asked. You look at what we're willing to spend on a mission to map Mars, which we've had many. And, a typical Mars mission, it costs on the order of $3 billion. And we've had a number of them. And one of them, we got feet and meters mixed up and it crashed. And so we had another one. So I asked, why is the public so willing? Because at the end of the day, it's the politicians who make these calls on the budget. Why are they so willing to throw out $3 billion here, throw out $3 billion there to map other planets? And I'm thrilled that they're doing that. I don't think there's anything wrong with doing that. But why can't we get them to put $3 billion, $3 to $5 billion would map the entire world ocean, our ocean, our planet's ocean. And why is that? And I've never really I've heard lots of different theories. Some people say spiritually, people like to look up and things are good, and you look down, things are bad. I have cynical reasons, like the corporate lobbyists behind the aerospace industry are just so much larger and so much bigger than those behind the marine industry? I don't know what the answer is, but I think if we can determine the answer to that question, we can solve the issue that you were talking about.
Can I just comment?
You should probably be selling more NOAA t-shirts.
Yeah.
Suppose I dressed him poorly today.
Lindsay, go ahead. Thank you, Will. Yeah, no,
Yeah,
let me just, before I go to Lindsay, let me just pick up on that, because I've had this discussions with NOAA's Science Advisory Board a number of times, saying that they weren't doing enough, that they weren't putting enough into that outreach and things like that. And these meetings are typically in Silver Spring at the Hilton Hotel there. And it's right next to the big Discovery Channel building. It's Discovery Channel is a huge building in Silver Spring, and it has all these murals around it. And I pointed out one day as I walked from the hotel I was staying at, or NOAA headquarters or something, to where the meeting was, that if you look at the murals around the Discovery Channel building, there are probably 6 or 7 of them are underwater ocean scenes, and only 1 or 2 are space scenes. So the Discovery Channel recognizes that the public will grasp on that, but why can't NOAA raise to the level of NASA in terms of grabbing the public's attention? Okay, no, I'm sorry, Lindsay, go ahead.
I agree totally, Larry. And I think one of the things is we're all scientists and engineers, and we love what we do, but we don't know how to push it out there. And as you know, from the Ocean Exploration Trust, that is one of Bob's goals. It's like you have to. It's not just an add-on to what we do. It's part of the function. And I always say to people, we do 3 things. We explore, but we have outreach and we have education. And the exploration is more just a vehicle for the outreach and education. And you have to have a dedicated group. So if it's $1 billion to do something, you better have a couple $100 million out there to actually do it and commit those funds when you do it. You can't just let it happen and think people are going to be excited about it. You have to have the right people and the organizational structure to really promote that. And really, you're marketing the ocean. And unless we do that, I don't think you can get people excited. It is exciting, and people that see it are excited, but you've got no one. We have a small, I look at exciting things we find, and you get, 100,000 people saw that. And it's like, oh, that's cool. And it's like, no, it's not. There should be millions of people, that's, I think, exactly what Doug is saying.
Yeah, and in a sense, it's unfair to compare NOAA to NASA. If you look at NASA's exploration budget, it's 1,000 times or so larger than NOAA's exploration budget, and I suspect their outreach and PR budget is equivalently 1,000 times larger. But then the question is, why is that? And that may come back to the business side of it, the lobby side of it that I talked about. I don't know. I don't know what the answer is.
So Larry, just could you fill us in on the Seabed 2030 progress or program, and has it moved since last year or 2 years ago?
Sure. Yeah. Okay. Yeah. Okay. So Seabed 2030 is something funded by the Nippon Foundation in collaboration with JEBCO, with a goal of mapping the global ocean by 2030. It's an aspirational goal. I don't think any of us really, at least any of the doers, really believe it'll absolutely happen. But the more we talk about it, the more we engage people, the closer we get. When we started in 2017, 2018, we keep track, at least through the publicly available data set. So it's a JEBCO database. 6% only 6% of the ocean had modern multi-beam data associated with it. By a year later, 2019, it was 16%. So that was a huge increment. The next year, it was 19%. And this last year, it's 20.6%. Now, the problem we face is that a lot of that is really coming from the fact that Seabed 2030 has really gotten quite a lot of publicity, very good publicity, and that's embarrassed a number of people and engaged a lot of people into contributing data that they had in a drawer somewhere, or just sat around. So a lot of that was data mining, And we're running out of that data to mine. Although every day, I mean, it's amazing. Every day we discover somebody else who just has a pile of data somewhere. We just got a whole bunch from Finland. And that's the kind of thing that happens with enough kind of public awareness. You know, somebody in the government says, yeah, we can give them all of the data that our Navy collected, but we give it them at 100-meter resolution, not a 10-meter resolution. And that's fine. And so those things are starting to happen. And that's what a lot of the effort is, but we're starting now to go into the next phase where we're starting to want to promote the collection of data. So there is something called the Frontier Ocean Mapping. The Nippon Foundation from day one has never said they're going to pay for the collection of data. They've always said they would never pay for the collection of data. And we're trying to convince them that it's not going to happen unless somebody pays for the collection of data. And they need to start setting an example. And so they have, with what they call the Frontier Ocean Mapping program. So we've had JEBCO student alumni out on a number of vessels. If any of you have a vessel that's transiting somewhere that you can demonstrate you wouldn't have collected data if there was no operator on, the Nippon Foundation will pay to put an operator on. That's what's happening with Victor Vescovo and all of his, not when he was at the trenches, but all of his transit between his trench dives. He would pay for people to be on board to do the mapping at the trench sites he was going to dive at, but getting from trench A to trench B to trench C, the Nippon Foundation paid for JEBCO alumni to be on board, and that's been a nice addition. But they're also, and we pushed them a little bit. They paid in part for the sail drone transit, as long as we can guarantee that we were collecting new data. They would pay for the new data collection on that transit. So that's probably the closest to real data acquisition. And then they're entertaining modes that if you can demonstrate that a ship is going to some very remote area, and probably unlikely that other people will visit there in a long time, that they will pay for incremental ship days for a few days, 5, 10 days or so, to try to maximize just for mapping. And so they are moving into that, and they're starting to, for the first time, to acknowledge that they need to go on a global fundraising campaign, because to do something like this is going to take an international consortium, an international effort, and to be honest, get governments involved. The U.S. is doing its share. The U.S. is saying it's going to map its entire EEZ. That's in the spirit of CBED 2030. That's a big step. And if every country did that, we'd get a big chunk done. So I don't know if that answered your question, but that's kind of where things are now. And so they also, for our industrial partners, they also we have another fund for technology, for new technologies that can enhance the efficiency of ocean mapping. And so if any of you have ideas about that, get in touch with me and I'm happy to pass them on. And so again, it's not a huge amount of funds, but I think that they'll evolve into a point of being willing. That was part of the idea with Sail Drone too, that was under that auspices, that they're looking at technologies that could help solve the problem. And I should say, just today, we've learned that we just got funded to build an Argo float that has an echo sounder on it. So hopefully in a few years, we'll see every Argo float with an echo sounder on it. So we got funding to build one. We'll see if that works, and then we go on from there. Anything else? And nothing bothering you? Let's see.
I was going to say, this is Tammy Frankston here. I just had a
Tammy,
quick comment.
Nice to see you.
Yeah, nice to see you too, Larry. I know that we haven't heard much from, John Hughes Clark at all, but I did see him lingering in the background. And he's another one of those ones that we're always interested to hear about his wobble tools and error models that he's working on. But I feel like me personally, I've always struggled to kind of understand how to get in and really start to learn and work with his tools and what he's working with. And I don't know if there's a better way that commercial industry can interact with him and his team and have access to and maybe help to bring to life some of his research in a commercial way. And I just know that that's one area in particular. I know he hasn't been around CCOM quite as long as the rest of you, but we always would be more interested to hear about John's work and how to better interact with this team.
His spirit has been with us from day one. And I'm really glad you asked that question, because I think I did a terrible job of presenting Brandon stuff. I just said they're doing it and that's it. So maybe John, if you did fill us in on where Brandon is on that.
Yeah, I mean, he continues switching to real data. That it's not hard to get rid of tens of milliseconds of latency and gross sound speed errors. It's the really subtle things now, and trying to fix what we used to think were bad. Nobody is that bad anymore, I hope. And one of the things we've really realized is the environmental aspects. A lot of what he's chasing ends up being variable oceanographic environments. And so his tool is now working on real data. And we're always careful. We can solve the old single sector systems quite easily, but it's the multi-sector that remains the challenge, and more of us use them. And what he's found, though, is he's not keeping up with real time. So there's a big debate. We originally wanted everyone to have a tool that was just sitting there telling you you're starting to have a problem. And at the moment, you have to look back through hours of data. So I'm not sure. It's not the most exciting thing, integration, but it's with us all. And maybe we should, I hesitate to say that, should we have more training in this? Because there are tools, and it's not that the community ignoring, whether it's Keras or QPS or other software manufacturers, they now can do reintegration. At the moment, they're slider bars. And so it might be worth having special sessions, not at this USHC, but in the future, where there's that closer contact. I know a lot of the software developers, they all come from New Brunswick, thank God. And maybe we need to make that more generally available.
That would be really great, John. Thank you.
Bridget, I see your hand up. That's high tech.
No, that's applause.
No,
oh, that was applause.
Actually,
okay.
Yeah, that was applause. I loved the training idea.
Yeah. So I apologize. I always mix those two up.
The other thing, just to point out on that, the other part of Tammy's question was about getting involved and making commercial versions of things that happen at the center. We should maybe just comment on that as well, Larry, if you want to do it, or I'll do it.
Oh, why don't you go ahead?
Okay. So this is something where I think Larry said right at the very start, the people in our industrial partnership program that get the most out of the industrial partnership program are the people that are actually at the center more often. Everybody's busy, and so it's not always feasible for us to chase you down and say, hey, we've got a really good idea you should think about, right? It's one of the reasons we do things like this and do the annual report, is to try and get out what it is that we're actually going on. But we're kind of relying a little bit on people in our industrial partners recognizing the opportunity and coming to bug us and say, hey, can we talk about this? We have a variety of mechanisms that we've used in the past to get intellectual property licensed. Most often that's been non-exclusive licenses, although we have done 1 or 2 exclusive licenses for certain technologies that we didn't think were going to be of general interest to lots of people. So we have different options on that. And we're usually fairly flexible about the terms of them. The things that we've licensed most frequently typically go out with a very permissive license that has a one-time fee of $1,000. So it's not an expensive proposition for you to get into. So we're certainly willing to support that. Some researchers are more focused on that than others. So it may take a bit of effort, but it's certainly not something that we would reject. But like I said, it does rely on people in our industrial partnership program recognizing the opportunity and coming, like Lindsay did for many years, to bug us and say, hey, look, can we do this? Can we do this? Can we do this? That's probably the most effective way of getting these things out.
Well then, John, consider this your warning that, maybe I'll be bothering you here in the next couple of months.
Okay, noted.
Can I make a comment again about just the general transfer operation, I guess, Larry? Just when I as Brian mentioned, I used to come in and bug you guys, but I always thought that maybe
I didn't mean to suggest that we didn't like you doing it, Lindsay. We
No.
very much appreciated you doing it.
it seemed like there should be someone from, we always said that there was so much more that people don't know that's being done. And it's opportunities like this, you get a little look, but you don't really know. And it seemed like there was an opportunity to have that kind of transfer from research to operations person there that was sort of working on behalf of all the industrial partners that could coordinate that and do that. And I did that for a few of the companies, you know, as a separate to my other after QPS. And it seems like there's still an opportunity to benefit from that if there was someone that could kind of help leverage that and act proactively work with the companies.
Yeah, we've talked about that quite a bit, and it's an intriguing concept. You know, we are funded by NOAA and not by our industrial partners. Our industrial partners offer a contribution in kind of some sort, but it's not anything that can provide a position or anything like that. And so, first and foremost, we would have to convince NOAA that that was worth funding, because that's the only way we could pay a salary if we put somebody online. Unless we turn around and something I've always tried to avoid, but we say, you know, if each industrial partner contributes $2,000, we could probably support a salary for somebody who can play that role. If you collectively thought that was a worthwhile thing to do. I think it really comes back to what I said and Brian repeated it, is that it just depends. There, some of our sponsors, you know, do come. We will have, you know, every few months, a day or two meeting with them and have great discussions, and we learn and they learn, and I think they're taking full advantage of it. Others don't, I guess I'm, you know, I don't want to push anybody into doing something they don't want. And so I leave it to the industrial sponsors to be the aggressors in finding us and seeking us out. But if collectively, and maybe it's something we can take up at a meeting next year, if collectively everybody thought that having a dedicated person who would, you know, have the job of making you aware on a monthly basis of what we're up to and the opportunities would be worthwhile, then again, we just have to, you know, I hate to say it, we're a soft money place. We have to figure out how to pay for that. Okay.
Larry,
yeah.
so
Go ahead.
Just paying for that, you know, I always jump in when I hear money. It really is $1,000 or $2,000 for each of us. I mean, I would say that's not a lot. But have you ever asked us for the money? Because short of giving you software, you've never asked for a monetary donation.
No, we haven't, and in part that comes from my 10 years at University of Brunswick, where the only way we were supported was by large monetary contributions from the private sector, and I just hated doing that, and that's why I've just been so happy in the mode we're in now, where I don't ever have to ask you for money. We're very fortunate to be well funded by NOAA, and then lets us interact with the private sector and not in a mercenary way at all. So again, you know, a couple of $1,000 asking you each, but for it to work, then everybody would have to make the contribution. Some would and some wouldn't. I don't know.
Yeah, I should clarify. Sorry, Brian.
So thanks, Lindsay. I should clarify, Harold. When I said that, what I meant was that's what you sign on dotted line for when you get a license for the software, but only if you get a license for the software. We've, like Larry said, we've never asked for any money, you know, up front. But you know, we're not entirely naive, although we are academics, so it comes with the territory. A lot of the early licenses that we signed up for software that we were licensing, particularly stuff I was involved in, also had a clause in it that said you had to become a member of the industrial consortium, which put you on the hook to then give us stuff to aid the university. So if we add up the aid in kind we've had from the industrial partners, you people, it comes to several $1 million a year that CCOM doesn't have to spend to buy the copies of Chimera and Fledermaus and HiPAC and SolarWiz and so on and so on and so forth, or borrowing hardware from our friends in the hardware manufacturing business. So it's been a big benefit to us. I honestly wanted to license things for $1, but the university just wouldn't let me do it. So that's a little bit more.
Yeah, the interesting thing is that this argument which Brian makes, which is absolutely correct. I mean, we benefit phenomenally from what you all offer us in kind, it really is a tremendous benefit that does add up to several $1 million a year. The university, that means nothing to them. They would much rather have us charge you some fee and a large licensing fee and a royalty fee and things like that. But we've pushed back and fought back, and so far.
I would also comment on that, Larry, from what it seems easy from what Harold said, just $1,000, $2,000. But when Brian and I did that little project and we went out to those all the industrial partners at that time, it was surprising to see what industrial partners wanted. It was so varied depending on where they came from, where they wanted to get access to the research, whether it was the software, early access, and those sort of things. I think it'd be very difficult to define how you, and it's almost tailored for like every one of them. So you would say, well, okay, everybody has to make the effort. My thought on having someone was like, yes, it doesn't have to be you to organize that. We talked about having a kind of a non-profitable person that could act as a, directly separate to the lab, that they could have as a consultant kind of doing that for them to investigate that. But I think just I agree, the simple approach of people paying wouldn't work, because people want so much different and they contribute so much already. We can contribute a ship stay, and it's like, that's way beyond a lot of things. So anyway.
KB.
Hello.
Hello.
I wanted to maybe join Harold here. It's you've got most of us here, and we have a little button that says, I like this idea or not. And you said you're hesitant to ask. Why don't you just ask now? Everyone's here. Say, would the industrial partners be interested to throw in $2,000 a year to get this going and see what happened? Don't want to put you on the spot, but I guess I kind of am.
well, but before I even ask, I have to turn to my program manager and say, would Noah allow us to do it?
Yeah.
How would Noah feel about that?
Well, Larry, one of the reasons we have CCOM and JHC separate is so we don't get in the middle of these things. So I have no comment to make about that.
So those of you who know how to raise your hand, I have never quite figured out how to raise your hand. Well, I guess I have figured out how to raise a hand. I haven't figured out how to clap. That was the one I haven't figured out how to do. How about, just so we don't embarrass people, it can be very subtle. Some people don't have their cameras on, and we don't have the full group here at all. When I did my head quickly, when I said $2,000 each, that's the full 58 members, and I don't think we have that. But if people kind of give a nod, do you think $3,000 each to create a position that would basically be dedicated? We can try it as an experiment for a couple of years.
So there's a thumbs up button too.
A thumbs up. Okay, well, I see one.
I don't know where the thumb up button is.
In the end,
you've already spoke. We know your view. Okay, so there, I'm seeing some. I'm not seeing all, but I'm seeing some. So we will.
Bear in mind, the thumbs up thing goes away on its own after a while.
Oh, it does. Okay.
You might want to raise hand because they stay until.
Okay, but I mean, I'm not counting. I'm just getting a general impression. All right, so we will take that up and internally and see, and it may be the university might be willing to support something like this too. But if I got the university involved, then they'd want to start getting royalties. They're not going to do this unless they can see a big return on their investment, and they don't. The in-kind contributions you make, which are so valuable to us, they don't acknowledge. So,
well, Larry, from Noah, I will at least look into whether there would be any objections.
And if Noah
to having a person on staff under
if
the
Noah
grant
was really enthusiastic about it, we could use some of the grant for it too. I mean, if Noah,
that's what I would ask about.
Yeah, and that would be great if we can underwrite it with a grant. Then we could really do it for.
I think you'll learn a lot if you try this for a year, for a couple of years, and you'll see, like, you gotta throw stuff at the wall, see what sticks.
Yeah, no,
and you might find that
although
this didn't really get what we wanted, but oh my God, a lot of other different ways to do it.
Yeah, do remember that Lindsay and Brian did have that NSF grant that kind of looked directly at this question. And so I think we did learn a lot from that.
Mm-hmm.
So,
there might be other models as well. For example, for some organizations, it might be very easy to justify charge for some sort of service that you haven't charged for much more easily than just a membership fee. So for example, for the companies that are coming and doing something with you for their advantage in your facilities, maybe there's a small nominal charge that they can easily put into their budget for their overall project much more easily than subscription fee to being a member that would cover the same amount of total costs.
Okay, we'll talk again amongst ourselves and with others, with probably some of you, about potential models for this. But you'll see why I'm such a successful businessman, and here I am arguing with you about, please don't send me money. So the perfect road to success. Okay, Jerry, is that a hand up, or is that vestigial from a vote, or do you have a question?
No, that was from before. I punched a bunch of buttons and shit popped up on my screen. So
okay, that's great. Okay, well, we're a little beyond 4 now, and unless somebody has something terribly pressing, let me once again thank you. Let me apologize that I run through this so quickly, but it's the only way we know how to get it done in an efficient and concise way. And let me mostly apologize for what a different, I can't take full responsibility for COVID and all that, but what a very different year we've had. And let's hope again that next year we'll be able to come together and really spend some time seriously with NOAA leadership. Maybe we'll have a plan for you for this, the idea of we'll call him an industrial liaison, or her, an industrial liaison type person from the center. And maybe we've grown to that point where we really can think about that. I always get nervous about that kind of thing, but I like JB's suggestion of throwing something against the wall, see if it sticks. As long as if it doesn't stick, you don't get upset. We'll move on from that. And so unless Andy, Brian, any closing final words? Brian is waving okay. Andy is smiling. That's always good.
Other than just to thank everybody for taking the time out of their day to come and listen to what we're doing. We always appreciate the opportunity to try and communicate what it is that we do, and hopefully start some ideas for collaborations.
Okay, and I should say that the university, while not fully open for business, we are certainly in a position now, particularly if you're vaccinated, that you can come visit, and so if you would like to follow up with an in-person visit, we can accommodate that.
Small update on that, Larry. Just since we've been on air, as it were. There's been an email you probably haven't seen yet that came out from the president that says that the university expects to have everybody back on campus on August 16th.
Oh, fantastic. Okay, all right, and let's hope it stays that way. New Hampshire's done pretty well, I have to say. So, okay, then again, thank you all, and hopefully we'll see you all next year at UNH, plus more. Goodbye.
Thank you, Larry.